So today we are going to discuss about quality management. Quality management. So what is this quality management? Suppose in previous topics we discussed software quality. So software quality always depends upon based on the producer point of view, based on the customer point of view, quality is different. So who is the responsible to give better quality application to the client? This quality management. This quality management. So here, this quality management is divided into two parts. One is QA, second one is QC. QA means quality assurance. QC means quality control.
Control.
Yes. So QA management people is responsible entire life cycle. Because in SDLC there is life cycle is there na requirements, analysis, design, coding, testing, release and maintenance. Each and every phase they are monitoring QA people. So the main process of quality management is no defects in final product. No defects in the final product. QA team will involve entire life cycle. If any weakness is identified, simply they give some proper suggestions. So who are the members in QA? Quality assurance people, high level management team, domain experts, technical experts. These are all the members in the quality assurance. QC means we are all comes under QC team, quality control. When they can involve QC people after product developed, before deliver application to the client, it is our responsibility, no defects. So main intention of QC team is identify the defects and before releasing no defects in the product. So quality management is process of preventing defects while developing an application. The main process of this team is no defects in final product. It is a process of preventing defects in the development of application. The aim of this process is no defects in final product. So before releasing, no defects in the final product. So this quality management divided into two parts: quality assurance. Second one is QC. QA and QC. The first one is QA. So QA team define the development process of application to prevent defects in application. QA team will define the development process of application to prevent defects in application. These people involve the entire life cycle of SDLC. Suppose if they can find any weakness of the any phase, yes, they will give proper suggestions to improve the strength of the development process. So QA team involved throughout life cycle to monitor and measure the strength of the development process. So, if any weakness identified, they will provide suggestion to improve the strength of the process. So QA team involve the entire life cycle. If any weakness is identified, they will give proper suggestions to that team. So who are the members? High level management team, domain experts, technical experts are the members. Second one, QC, quality control. Means we are all the test engineers all comes under QC team. Why? Because the main intention of QC is to identify the defects. So whenever the product is completed, after product, so QC team involved after product is developed. Means we are. Why? Because once the application is completed, then that is given to the test engineer for the purpose of identifying defect. So QC team involved after product is developed in order to deliver in the defects. In order to deliver the defects. Why? Because once you identify the defects, we are intimated to the developer. So the main intention of QC is to deliver the defect. Those should be resolved before deliver application to the customer. In order to deliver in the defects and make sure those should be resolved before deliver application to the customer. So that is QA and QC. These two people are comes under quality management. These people are responsible to give the better quality application to the customer. So QA people involved entire life cycle. QC people are involving after product is ready to identify the defects and those should be resolved or not before deliver to the customer. That is the QA and QC. So at the time of QC or QA, so what are the testing methodologies are there? What are the testing methodologies we are implementing? There are three types of testing methodologies are there: white box, black box, and gray box. So those are called as testing methodologies. So by using these methodologies, we are validating application source code as well as functionality. Why? Because every application have two are there. One is source code is there. Source code means to develop an application, developer they connect some programs, means that is source code. So by using these testing methodologies, we are validating source code and functionalities with the best possible combinations. We can use three methodologies are there: white box, black box, and gray box testing. So to validate an application source code, and functionalities. With the best possible combinations. White box testing, black box testing, gray box testing. These are all the three methodologies are there. White box, black box, and gray box. White box means it is done by the developers only. Well, because with the help of programming knowledge only, it is possible to perform the white box testing. So that white box testing is also called as glass box, clear box, open box, or structural testing. So white box testing, different names are there. If we want to perform white box testing, compulsory we should have knowledge on the programming. Without having knowledge on programming, it is not possible to perform white box testing. So what is white box? Validating one application source code using programming knowledge is called as a white box. It is performed by the developers only. So white box testing is responsible to the developers. After that, black box means without having any knowledge on the coding part, without having any knowledge on the coding part, we are validating application functionalities based on BRS documentation. That type of testing is called as a black box. That is also called as closed box. As a test engineer, we are performing black box. Why? Because we don't have any knowledge on the coding. That's why we are responsible to the black box testing. The first one, white box, WBT, white box testing. So it is also called as glass box or clear box or open box, or one more name is there, structural testing. So black box can also called as a glass box, clear box, open box, or structural testing. So what is the white box testing definition? Validating the application source code by using programming knowledge is called as white box testing. Validating one application based on the programming knowledge is called as the white box testing. So coding means who will perform? Developer, they have idea about the coding. As a test engineer, we have zero knowledge on the coding part, so it is not responsible to the test engineer. So developers who will perform, it is performed by the developers. So once it is completed, they are verifying complete source code. After that, application successfully implemented, it is given to the test engineer. Now as a test engineer, without any programming knowledge, we are validating an application based on BRS. BRS means Business Requirement Specification. Last session already we discussed about the BRS, URS and SRS. BRS will be corrected by the BA people. In that, what kind of application we are developing, how many users are there, what are the required services for those users, everything is available there. So based on BRS only we are testing it without having any coding knowledge. That type of testing is called as black box testing. In general, software test engineers will perform black box testing. So what are the techniques are there to derive test cases under black box? There are three techniques are there: BVA, ECP, and error guessing. The second one, black box testing. So it is also called as closed box. White box is called as open box. It is called as a closed box testing. So what is this black box definition? Without having any programming knowledge, validating an application based on requirement, that is BRS, is called as black box testing. So see, what is the black box testing? White box means with the knowledge of programming only it is possible. Why? Because they are validating source code, but we are validating front-end functionality. Front-end functionality. So this is the definition. Without having any programming knowledge, we are validating one application based on the requirement. The document is called as BRS documentation. Is called as a black box testing. So who will perform? In general, separate testing team will perform black box testing. So what are the techniques we are using to derive test cases? There are three techniques are there. Later on I will explain all these. BVA, ECP. First two are very important. In any interviews, if you got any real time, compulsory they can use this BVA and ECP. BVA means boundary value analysis. ECP means equivalence class partition. So BVA, boundary value analysis, equivalence class partition. Later on in the next topic, our topic, next one topic is the testing evaluation SDLC. In that there are 6 pages are there. In that, in one topic we will discuss about that BVA and ECP in detail with examples. I will explain what is that boundary value analysis, what is the equivalence class partition. Based on that, how to prepare test data we will discuss in the upcoming chapter. So what are the black box testing techniques? These BVA, ECP and others. The third one, gray box. Gray box is nothing but combination of white box and black box. So who is having both programming knowledge as well as complete requirement knowledge, then he is responsible to perform the gray box. But real time, we are not implementing the gray box. Only white box, black box and UAT we are performing. So gray box testing, GBT. It is combination of white box testing and black box testing. To perform gray box testing, we should have programming knowledge as well as complete requirements knowledge. Then only it is possible to perform. It is performed by test engineer or developer. Because who is having both the knowledge, then it is possible to perform gray box. But in real time, we are not implemented this gray box. Only we are implementing white box, black box, and third one UAT, user acceptance. Why? Because white box will be done by the developers. After that, as a tester, we can perform the black box. After that, we are hand our application to the client. So client will perform UAT. So these three are the validation techniques in real time. That is about the testing methodologies. So after this, quality management, QA and QC, after the testing methodologies, now the one more important, very important topic is testing levels in SDLC. This is some important and big chapter, testing levels. How many levels are there in testing? There are totally 6 levels are there. Review on requirements, review on design, unit testing, integration testing, system testing, UAT. User acceptance testing. These are all the 6 levels are there. Review on requirements, review on designing, unit testing, integration testing, system testing, and UAT. In the first one, review on requirements. So review means, so starting first topic, Dhoni,
Sir, fine, fine.
1 second. So 6 levels are there: review on requirements, review on designing, unit testing, integration testing, system testing, and UAT. First one, review. So in starting first class, we discussed about software testing. Software testing means verification and validation of a, means at the time we are discussing verification. What is verification and what is validation? Verification means whether one application is properly implemented or not, that is called as verification part. It is also called as static, means just we can review only, we are not validating anything, so that is verification. So here you can see review means just we can review only, we are not validating anything. So the first two are comes under verification part, next these four under comes under your validation. So starting class, first class, you can observe I am given testing definition. What is the software testing? Verification and validation of a software is testing. So what is the verification? I am given definition also here. What is validation? I am given definition. So now come to this topic, same. These two are called as the verification part. Why? Because there is no validations. Only just we can review the documents and identify. These four are comes under validation part. Here we are performing dynamic testing, unit integration only. So first one, review on requirement, means whenever the requirement documents are prepared, completed, then they perform review on those documents to verify some factors. What are the factors they are verifying? Means whatever the customer business needs, all the business needs are covered or not in the BRS documentation. Yes, customer is giving some needs, so all those needs are covered or not, those requirements are correct or not, those requirements are understandable or not, and one more finally, those requirements are reliable or not in terms of technology to develop. So just they can review the customer business needs. Whenever requirement documents are prepared, they perform one review to verify following factors. What are the factors? Customer business needs, all the business needs whatever he is specifying, everything is covered or not in the document. Those requirements are correct or not. Is it understandable or not? Is it possible to implement with respect to our technology or not? Once it is completed, yes, then they go for design documentation. Again, they can review on the designing. So first, review on requirements. Then they perform review on document. So whenever requirement documents are completed, then they perform one review. So what are the factors they are verifying here? All the customer business needs are covered or not, and those requirements are correct or not, and requirements are understandable or not, and requirements are reliable or not in terms of technology to develop. So these are all the four factors. Yes, whatever the customer given business needs, all those business needs are covered or not, and whatever the requirements, those requirements are correct or not. Is it understandable or not? Is it possible to develop with respect to our technology or not? Once they can review all these, after that they're going for the design documentation. So the second level is review on designing. So first review on requirements, first phase. Second phase review on designing. Again here also, after preparation of design document, one review will be conducted to verify the following factors. First factor. So whatever the requirement documents, in requirement there are some customer requirements are there. Some 5 or 10 or 15, 20 something requirements are there. In BRS documentation they can use requirement 1, requirement ID 2, 3, 4 like that, maybe 25 requirements are there. So all these requirements are covered or not in the designing. Why? Because based on the BRS FRS only designing is there. You can see in last class already we discussed review on requirements, analysis, designing part is there. So in last class, this is the class last class. Review on requirements, sorry, requirements collection, analysis, design, coding, testing. So here design will be done by the design architect. He will prepare three types of documents: GUI designing, database designing, application. How they preparing? Based on that BRS and FRS. So here what we have to review? So all the BRS documentation requirements are covered or not in the designing. Those design logic is correct or not? The design logic is understandable or not? Is it possible to implement or not? All the things they can review here. First one, all the requirements are covered or not? The design logic is correct or not? Is it possible to implement or not? Is it understandable or not? All the things they can review in this designing part. All the requirements covered or not. that design logic is correct or not. Design logic is understandable or not, and is it possible to implement or not. Everything they can verify. So for reviewing this, what are the factors they can, what are the techniques they can use to review on requirements, to review on designing? They can use some verification techniques are there. Yes, here you can observe. So in verification, there are some techniques are there. In validation, some techniques are there. So verification techniques are peer reviews, walkthroughs, inspections. Validation techniques are white box, black box, and gray box. So after that, later on, I will give one diagram. In that, everything is clear about this diagram. See. So testing means both verification and validation. Under verification, there are three techniques are there. See this diagram. Software testing. Later on, I will explain this document. Okay. In this chapter, I will explain this. Software testing, verification part, validation part. So verification, are we developing product right or not? It is performed on BRS, FRS and test design. See, the techniques are peer reviews, walkthroughs, inspections and checklist. Validation, it is a dynamic testing. Are we developed right or not? We are performing on source code and functionalities. What are the techniques? See, three techniques: white box, black box, and UAT. That's why I'm telling. Testing methodologies are three: white box, black box, gray box. But validation techniques are white box, black box. In real time, we are using third technique, UAT. Later on, we will discuss about this document. Okay. Now, up to here, what are the three techniques? Review on requirements and designing, peer reviews, walkthroughs, and inspections. So next note, they use verification techniques on requirement review, and design review. Peer reviews, walkthroughs, inspection. This year called as verification techniques. Peer review, walkthroughs, and design inspections. So what is the peer review? What is the walkthrough? What is the inspection? There is one concept is there, V model. In SDLC models, there are some models are there. V model, agile model, waterfall model, prototype model like that. So in V model, we will discuss about what is the peer review, what is the walkthroughs, and what is the inspection. So this is first part, review on requirements and review on designing. Next one. First validation technique is unit testing. So the first validation technique is unit testing. So what is the unit or component? So it is also called as a component testing. So who will perform unit testing? It is done by the developers only by using white box testing techniques. It is the first validation technique. Why? Because suppose the application is there. For easy development purpose, they can divide into multiple modules and they are given to the multiple developers. Suppose one unit is nothing but some portion of application, also called as a component. It is given to the one developer. He is responsible to validate that module only. So validating individual components within the system is called as a unit testing. Suppose if there is any bank application is there, if there is any bank application, there are different modules are there: savings account, recurring deposits, In savings, deposit, withdrawals, funds transfer, like that, multiple are there. At that situation, that application will be divided to multiple modules and given to the multiple developers. Developer 1, developer 2, developer 3, like that. I will show one diagram. There is one bank application is there, login module is there, savings module is there, deposits, withdrawals, funds transfer. There are 5 modules are there. 5 modules are given to the 5 developers. Developer 1, developer 2, developer 3, 4 and 5. So what is unit testing? Developer 1 is responsible to validate only this login module. Only this login module, yes. He is responsible to the login only. Why? Because he is not responsible to the savings, he is not responsible to the deposits, he is not responsible to withdrawals. So what is unit? Validating individual component within the single system is called as a unit testing. Maybe because he is the developing that module, so he is responsible to validate that module only. That type of testing is called as a unit. So it is also called as component testing. After coding, developers will perform unit testing by using white box testing techniques. White box means with the knowledge and programming they can perform. Already we discussed just now what is the white box. So white box we will perform developer. See, this is the white box definition. Who will perform? Developers. So by using this technique, they can perform unit testing, the first part. So it is also called as component testing. So after coding, developers will perform unit testing by using white box testing techniques. It is an initial validation technique because it is the first validation technique. So what is the unit testing? Unit testing means validating individual components within the system. Called as unit testing, yes. So who are the developer developed a module is the responsible to validate that individual module. Those type of testing is called as unit testing. So what are the factors they are validating? Means they are always validating source code. They are not validating functionality. Functionality means suppose you can see if I am developing an application, front end functionalities are there, back end source code is there. Suppose if you go to Google, in Google, as a test engineer, we are validating front-end functionalities. Means, suppose Gmail link is there. Is it working or not? Yes, you can click it. Yes, it is working. You can go to the back. You can click on this. Is it displaying applications or not? Yes, it is displaying. Suppose your Google search button is there. If you want to type anything, clicking on the search button. Yes, search button is working or not? Yes, it is working. So front-end functionalities we are validating, that is black box. But developers, they are validating back-end coding. Coding means source code they are validating. Suppose if any defect identified by the test engineer, we are intimated to the developers. Then developer they can check that is there any code error is there. Why? Because why the defects are present in the application. In first class we discussed. See here, I am given one note also. What is the defect? Bug, failure. The deviation between expected results and actual result in AUT is called as defect. I am given one note also here. Why the defects are present? In general, defects may present in application due to human mistakes while developing an application like syntax errors and logical errors. So developers, if they perform any wrong errors in the programming, due to their mistake, defects are presenting. So once I'm intimated defects to the developers, they can check the code. Yes, where the error is there. Is there any syntax error or any logical error? They can verify. For that, they're using 4 techniques: statements coverage, loops coverage, conditional, path or branch. So what are the techniques are there? For this verification, they're using three techniques are there. First one, statements coverage. Statements coverage means, so whenever I am intimated some defect to a developer, first developer they can execute their program. Okay, first of all the statements are at least executed once or not, they can check it. Means, suppose if I am writing any core Java program or any .NET program, first we are compiling. Yes, is it compiling or not? After that we can run it. Then we can check that any errors are there. So first of all we can compiling means every statement are executing at least once or not. Then only I can check the output. Yes, is it correct output or not? Later on we will check it. So first any programming knowledge we can compile the program. If any errors are there, syntax errors, everything, at the time of compilation, it will display the errors. So that is first one is statements coverage. At least once. Okay, it is completed. Compilation is done. But at the time of execution, I will get the wrong output. So what is the problem? Maybe now logical errors are there. Syntactically, no problem. You can see either syntax error or logical error. Syntax error, no syntaxes, though no compilation. Compilation, there is no errors. At the time of execution, I get the wrong output means something logic is missing. Maybe in loops, I can give any wrong. Maybe conditions, if I can give any if else condition wrong, automatically it will give wrong output. If I am using any condition, yes, it will give wrong. After that, they are checking conditional statements. In conditions, if else conditions, we are using right expressions or not. Loops coverage, we are giving proper loops or not. Suppose if it is a month, January month, 31 days are there. We can write one for loop. For int I equal to 0, I less than 31. Suppose if I am giving I less than 30, in January calendar it will display only 1 to 30 days. 31st calendar it is not displaying. So if I can write the for loop, yes, suppose I want to print hi 5 times. So if I can write like this for int I equal to 0, I less than 5, I less. If I can print hi system.out.println, in Java we can write like this hi. Now tell me how many times it will print hi? Is it print 5
Okay.
times?
4 times.
4 times only. Why? Because as a programmer, I did some mistake. It is not the programming mistake. So I did some logic wrong. That's why error will come only 4 times. But your requirement is print high in 5 times. At the time, here I can give either less than or equal to. Now how many times it will print?
5.
5 times. Or else you can see, suppose if I can give like this, how many times it will print? 5 times. So two logics are there. If I can go I equal to 0, I less than 5, nice, okay. Or I equal to 1, I less than or equal to 5. Both are same. So these for loops, is there any mistakes are there in the loop conditions? So everything developer they will check it. Why? Because once I am intimated one defect to that developer they can perform all these statements coverage. Is there any mistake in the loops? Is there any mistake in the conditions, if else conditions, while loops, conditions, and everything they can check it. So second one, loops coverage. So verify loop statements are terminating as per expectations or not. After that, conditional. Conditional statements means we are using right expressions or not in the condition, if else condition. Suppose in if else, if I am given one condition, if that condition is passed, it will print the first term. If I can fail, it will give the else statement. Suppose I did mistake in that if else conditions, automatically the output will be wrong. So after loops, they can check the conditions. Is there any mistakes are there? Verify. We use right expressions or not in conditional statements. In conditions, everything is correct or not. Path or branch means verify the execution flow of the program based on condition either true or false. Means suppose if I go to the application, suppose if you go to any spice shirt, or if you go to create account in the Facebook, Gmail, they will give on radio button, male or female. Suppose in flights also you can see round trip, one way, multi-city. Either you can select only one radio button, one way, or if you go to round trip, okay, or if you go to multi-city, okay, done. That it is not possible to take all the values. Yes or no? So either you can select round trip, or you can select one way, or you can select multi-city. Same like that, if you go to the Gmail, if I want to create an account in the Gmail, yes, where is it? Create an account. Or if you go to Facebook, if I want to create an account, they will give radio buttons, male and female. Here, see. So which radio button? Only one button. That is called as path or branch. Either true or false, only one condition it will take. Verify execution flow of the program based on conditional false. So see, all these are important to the developers only. Why? Because as a test engineer, we don't have any knowledge on the coding part. That's why we don't bother about that techniques. So all these are take care by the developers only. Yes, 1 second please. Now see, so unit testing is completely done by the developers. So we don't bother about those things. Why? Because as a test engineer, we have zero knowledge in the coding part. So it is always done by the developers. Validating individual components within the system is called as a unit testing. These are all the techniques: statements coverage, loops coverage, conditional coverage, path or branch coverage. So unit testing means validating individual components. After validating individual components, they can integrate and they can create one application, that is bank application. Here they are validating interface between the modules. That type of testing is called as integration testing. The second level is after unit testing completed, they are integrated all those and they can test the interface between the components. That is called as integration testing. So integration, there are two approaches are there: big bang approach and incremental approach. Again, incremental three are there: top down, bottom up, and hybrid. Again, integration testing two levels are there: low level integration and high level. So integration testing is some lengthy concept. One class it will take the complete integration testing. After that, system testing. Now our turn will come. As a test engineer, we are performing system testing. So system testing is very, very important to the test engineer. Why? Because there are two types are there: functionality and non-functionality. In there, totally 6 plus 10, 16 testing techniques are there. So system testing is important to the test engineer. First unit integration done by the both the developers. So tomorrow's class, I will explain about the integration testing.